Hey everybody, I just wanted to run through a couple more examples with the transformations. So this one is going to be writing an equation based off of what we're given. So the order that you are given the transformations is very important because that's going to affect what your equation will look like. If the order is not followed properly, you're going to get a different answer than what you should be. Um, okay, so let's get started with the first one. So what we want to do is we want to take x squared and we want to apply a horizontal shift 8 units to the right. Okay, so 8 units to the right, right? If you remember your transformation rules, it should look something like that, right? So my value for c here technically is 8. Okay, so my new function is just simply going to be x minus 8 squared. Okay, so that would take a quadratic of x squared and move it to the right 8 units. Okay, so the next one says you have the absolute value, and then you are moving it up 5, followed by a vertical stretch by a factor of 3. Okay, so again, you got to remember the order that you do it. All right, so the first one, vertical shift 5 units up. Okay, so that's just simply f of x. You're going to take your original function and then just add 5 to it. Okay, so your new function now is going to be the absolute value of x plus 5. Okay, now the second part says a vertical stretch by a factor of 3. Okay, so I'm going to take my function that I have now, and when I apply a vertical stretch by 3, I'm taking my entire function and I'm multiplying it by 3. Okay, so you're not going to just multiply just the absolute value part, but you actually need to multiply the entire function. Okay, so what I'm going to call this, we'll call this h of x. Just to give it a different name, we'll call that 3 times g of x, right? So 3 times absolute value of x plus 5. Okay, so what that ends up being now is now 3 absolute value of x plus 15. Okay, so that vertical stretch now made that vertical shift, instead of up being up 5, now it's going to be up 15. Okay, so this is your new function based off of the order that you go in. Okay, letter C, f of x equals x cubed. So we have a horizontal shift left 3, followed by a vertical shift down 7. So this one's pretty straightforward. So left 3, okay, would put me at x plus 3 cubed, okay, and then I'm going to move that graph and I'm going to move it down 7. Okay, so that's would be your new function. All right, letter D says the square root of x, vertical shift up 5, followed by a reflection across the x-axis. Okay, so the first part is you're just going to move the graph up 5. Okay, so that's going to make it the square root of x plus 5. Okay, now when you do a reflection across the x-axis, right, that means that the negative 1, is on the outside of your function. Okay, so what I'm going to do when I take g of x now, okay, again, I need to put the negative 1 on the outside of that function. Okay, so it's going to look like this. All right, so again, you need to remember that you're going to apply it to every term that you see, not just the square root of x. Okay, so you have the negative 1 times the square root of x plus 5, which is going to give you negative square root of x minus 5. Okay, so that is your new function. Okay, so when you're multiplying by things, whether it's a vertical stretch or a reflection, you need to just kind of remember the order, and you need to remember that if it's a vertical stretch, you're applying it to everything, where a horizontal stretch would actually just be the x term. Okay, so my graph here is just f of x equals x, and we're going to move it horizontal shift 12 units to the right, followed by a reflection in the y-axis. Okay, so 12 units right. If this is my starting function, okay, and I move it 12 units right, I'm just going to actually subtract 12 from that, okay? So I know we typically say when you move it left and right, you want to make sure that that's inside the parentheses, which, I can leave it like that. But because it's linear, I actually don't need those parentheses there, so I'm actually going to get rid of them. So in this case, actually, a vertical shift down 12 is the same thing as a horizontal shift 12 units to the right. Okay. Now the second part says a reflection over the y-axis. All right, so if you remember when you're doing a y-axis reflection, the negative is on the inside, like that. Okay, so it's not being applied like the last one where the negative got multiplied to everything. Here we're just going to be multiplying the -1 to the x term. Okay, so your new function now okay, again, we're just taking the -1 and multiplying it to the x term, not the -12. Is actually just going to be -x minus 12. Okay, so again, it goes back to again the rules that we've been talking about. You just need to pay attention to what is whether it's being multiplied to the whole equation or just part of it. Okay, so the next one we have the absolute value of x, horizontal shrink or compression by a factor of 1/2. Okay, followed by a translation 4 units up. Okay, horizontal shrink by a factor of 1/2. Okay, so we need to remember that when we take this number here, I'm actually going to be multiplying it by the reciprocal. Okay, so if I put that underneath 1, that's going to give me 2. Okay, so that number there needs to go on the inside of my function. All right, so my function now is going to look like absolute value of 2x. Okay, and then the last part says you're going to move that 4 units up. So we're going to say g of x is absolute value of 2x plus 4. Okay, so that's a horizontal shrink by 1/2, and then a vertical shift up 4. Okay, the next one, x squared plus 1. So we have a translation 1 unit left. All right, so that's going to make me do x plus 1 squared. Okay, and I'm still going to leave the plus 1 there at the back because that was part of my original. Okay, so that part is done. All right, the next part says we're going to take that function and then we're going to move it 2 units up. So we're going to move it 2 units up. Okay, so that's going to give me now x plus 1 squared plus 3. Okay, so that is done. And then the last part says, okay, take that and do it by a vertical stretch of, let me change my color, vertical stretch by a factor of 2. Okay, so again, when you do a vertical stretch or a shrink, you're applying it to everything, not just the x term. So I'm going to take my entire equation here, and I'm going to multiply it by 2. So my new function now is going to be 2 times x plus 1 squared plus 6. All right, so again, that 2 gets multiplied to everything, not just your x term. Okay, now the last one. So x squared minus 2x. We have a translation 2 units left. Okay. Okay, so when you do a translation 2 units left, right? All right, that's what technically your function is going to look like. Okay, so we actually need to, because this has 2 variables, we need to apply it to both. Okay, so this is going to be x plus 2 squared minus 2 times x plus 2, like that. All right. Okay, so that part is done. All right, the last part, or the next part says we're going to take that, we're going to move it 3 units up. Okay. So I'm going to add 3 to my equation. Okay. And then the last part says we're going to have a reflection over the y-axis. Okay, so that means that wherever I see an x term, I need to replace it with a negative 1. All right, so remember, reflection over the y is going to look like that. Okay, so what I have now all right, so everywhere I saw an x term, I replaced it with negative x. Okay, so what I'm going to do is I'm going to simplify this a little bit because it's a little ugly right now. Okay, so if I take out the negative here, that's going to leave me with x minus 2. Okay, and I have minus 2, and then this is negative x plus 2 plus 3. So that's plus 2x minus 4 plus 3. So my final answer now is going to be negative x minus 2 squared plus 2x minus 1. Okay, so because of that y-axis reflection, some of my transformations here ended up changing, or not necessarily changing, but how it made my equation look, it affected that. Yeah, so that's just follow the order, and they're pretty straightforward. So again, if you guys have any questions, feel free to come see me, and I will see you soon.